everyone, welcome to my YouTube channel Easy Way to Learn. I'm Shailja and in today's math series we'll be doing some questions on circles. So let's get started, remain focused and follow the series. See, in this question it is said in a triangle PQ is 24 centimeters, QR is 7 centimeters and angle PQR is 90 degree. We have to find the radius of the inscribed circle. Okay, so using Pythagoras theorem we can find PR. So let's find PR. See, PQ is already given 24 centimeters. This distance and this distance is 7 centimeters. So using Pythagoras theorem we can find PR. So PR square is equal to PQ square plus QR square. So PQ is 24 square plus 7 square. So we get 576 plus 49. This is 625. So take under root of 625 and you get the value of PR, which comes out to be 25 centimeters. Okay, now let's come back to the figure. See, QB and QA are tangents to the circle, and we already know from the theorem that from the external point, when the two tangents are drawn, they are equal in length. So we know QB is equal to QA and QB is also equal to OA. So this distance is X. See, QB is X and AQ is also X. So BR will be 7 minus X. So this distance will be 7 minus X. And this distance will be 24 minus X. Again, tangent drawn from the external point are equal in length. So BR is equal to CR. So this CR will be equal to 7 minus X. By same logic, PA is equal to PC. They both are the tangents from the external point P. So PC will be, this distance will be 24 minus X. Now we can equate these two here. So PR we already know is 25 and PR is equal to PC plus CR. PC plus CR. So we can find X. See, 25 is equal to PC is 24 minus X plus 7 minus X. On solving we get 31 minus 2X or 2X is equal to 31 minus 25, which is equal to 6. So X is equal to 6 upon 2, that is 3 centimeter. So the radius of the inscribed circle is 3 centimeters. See, let's see this question. See, A, B, C are the 3 points on a circle. The tangent at C meet BA produced at T. Here, this tangent at C which is produced meets BA at T. Given angle ATC is 36 degree and angle ACT is 48 degrees. Calculate the angle subtended by AB at the center of the circle. That is, we have to find this angle BOA. We have to find this angle. Okay. So let's begin with this figure. See, OC, OB and OA are the radius of the circle. So we know radius from the center O, they all are equal. And radius is perpendicular to the tangent. So this angle OCT, this angle is 90 degree. This whole angle is 90 degree. So we can write here angle OCT is 90 degree. Reason, radius is perpendicular to the tangent CT. So here we can write radius is perpendicular to the tangent. So this is the okay. So OC is perpendicular to CT. Now we can find angle OCA. So angle OCA will be equal to 90 minus 48. This will come out to be 42 degree. And we can see triangle OCA is an isosceles triangle because OC is equal to OA. Hence, the base angles will be equal, that is OCA and OAC will be equal. That is this angle X will be equal to this angle X. So we can write angle OAC will also be 42 degree. Reason, you can write triangle OAC is an isosceles triangle. Hence base angles are equal. So from here we see both these two angles are 42 degree. Now here we see that angle CAB. Angle CAB is exterior angle to the triangle ACD. So I can write angle CAB, angle CAB is equal to 48 plus 36 degrees. Exterior angle is equal to sum of two interior opposite angles. So here reason, you can write angle CAB is exterior angle of triangle ACT. So this will be 84 degrees. So we know this angle is 42 and this whole is 84. So we can find angle OAB, that is this much angle. So we can write in triangle OAB, angle OAB will be equal to 84 minus 42 degrees. So this much angle was 42 and this whole was 84. By subtracting we get again 42 degrees. Okay. Again triangle OBA is an isosceles triangle. So base angles will be equal. So we'll write in triangle OAB, that is we are talking about this triangle. So we can write angle OAB plus angle OBA plus angle BOA is equal to 180 degree, angle sum property. Now this angle is 42, this angle is also 42 because it is an isosceles triangle, and we can find angle BOA. Plus angle BOA. So you get angle BOA is equal to 180 minus 84. Solve this, you will get the answer. It is 96 degrees. So using the isosceles triangle property, and in this question, see P, Q are centers of the circle. See P and Q are the centers of the circle with radii 9 and 2 centimeter respectively. PQ distance is given 17 centimeter. R is the center of the circle with radius x, which touches the above circles externally. It is given angle PRQ is 90 degree. Write an equation in x and solve it. So first let's write the equation using Pythagoras theorem, since it is a right angle triangle. So what we can write, PR square, see, PR square plus QR square will give PQ square. So PQ we already know, it is 17, so 17 square. And PR can be written as 9 plus 6. So we can write 9 plus x whole square plus, then QR is 2 plus 6, 2 plus x whole square. Now we'll open these two brackets using the identity. See, a plus b whole square. So using identity we get 81 plus 18x plus x square. Again here we get 4 plus 4x plus x square, and 17 square is 289. So let's solve it. We get 2x square okay, then we have 18, 22x plus, then 81 plus 4 is 85 minus 289 is equal to 0. So we get a quadratic equation. See, 2x square plus 22x plus 204 is equal to 0. So this is the equation. Now we can reduce it by dividing the whole equation by 2. So we divide the whole equation by 2. So we get x square plus 11x plus 102 is equal to 0. Now let's factorize. So we get two factors, 17 and 6. See, 17 into 6, 42, 4, 104, and 17 minus 6 is 11. Okay. So here we can write 17 minus x, 17 minus 6x plus 102. X square plus 17x minus 6x plus 102 is equal to 0. Or taking out common, we get x plus 17, and here take out 6, we get x. Okay, here there is a mistake. Here it should be minus 102. See, on subtracting, again here make a correction. So we get 102. So here we get x plus 17 is equal to 0. Then we get two brackets, x plus 17 and x minus 6 is equal to 0. So we get two values of x. X is equal to minus 17 or 6. So we'll ignore the negative number, and so the answer will be x is equal to 6. So this is your answer. Question: in the figure given alongside PQ and QR are equal. PQ and QR are equal. Angle RQP is 68 degree. PC and QC are tangents to the circle with center O. Calculate the values of QOP. That is QOP. That is, we have to find this angle, and QCP. QCP means this angle. We have to find these two angles. Okay. So we can begin this question with the understanding that PQ and QR are equal. Hence, the given triangle PQR is an isosceles triangle. So, using this property, we can easily find the value of x. So, let's write in triangle PQR, we can write x plus 68 is equal to 180. So twice x is equal to 180 minus 68. So we get here so value of x is 56 degrees. Now we know the relationship between angle that is formed at the center and angle that is formed in the any part of the circle. So this angle, that is QOP, is twice angle QRP. So using this property, you can write angle QOP, angle QOP is equal to twice angle QRP. And QRP is nothing but angle X. So you get 2 into 56. That is 112. Here also mention the reason that angle at the center, angle at the center of the circle is twice the angle formed, twice the angle at remaining circumference, twice the angle at remaining circumference. Okay. Next, if we see the quadrilateral POQC, again, sum of all the angles is 360 degree, and we know that radius is perpendicular to the tangent. So angle P and Q are 90 degrees, that is the sum is 180. So the remaining, that is this angle QOP and PCQ will be 180. That is these two angles are supplementary. So we can write in quadrilateral, in OPQC, angle QOP plus angle PCQ is equal to 180 degree. That is, opposite angles are supplementary, or you can give the reason. Angle OPC is equal to 90 degree and angle OQC is also 90 degree. So the remaining angles, the sum of remaining angles will be 180. So QOP is already known. It is 112. 1 plus angle PCQ will be 180. Then we find the angle PCQ. 180 minus 112. You subtract it and get the answer. 68 degree is the answer. So these two are the part of the answer, that is angle QOP and angle PCQ. So these two are the part of your answer. PT is tangent to a circle at T. If angle ABC, that is this angle, is given 70 degree, is given, and angle ACB is, this whole angle is 50 degree. Then we have to calculate angle CBT. For this, we have to join B to T. So let's join B to T and BAT, angle BAT. For this also we have to join A to T. Then we have to find angle APT. This angle also we have to find. So here we see that this CT is perpendicular to the tangent. Let's put it X, PX. That is CT is the diameter of the circle. So we can write CT is the diameter of the circle. CT is the diameter of the circle. See, CT, why it is said it is dia because this CT is falling perpendicular to the tangent PX, and we know that radius is always perpendicular to the tangent. So here you can write, since radius is perpendicular to the tangent. Now, if we see this triangle CTB, so this angle CBT is angle that is formed in the semicircle. So, angle CBT will be equal to 90 degree. Reason will be angle in the semicircle is 90 degree. Angle in the semicircle. Okay, so the first part is solved. Now we have to find angle BAT. So for this second part, first we need to find angle CAB. So in triangle ABC, using angle sum property, we can find, see, angle BAC. This will be equal to 180 minus 70 plus 50. So this will come out to be 60 degree. Okay. Now angle CAT is also 90 degree. Again by same logic, angle in the semicircle is 90 degree. And again we can write angle CAT is 90 degree. Reason is angle in the semicircle. So now we can find angle BAT. Angle BAT is equal to, see, this is 60 and whole of this CAT is 90. So we can write angle CAT minus angle BAC. So what you get, 90 minus 60, that is 30 degree. So second part is also solved. It is 30 degree. You get 30 degree. Now we have to solve the third part. See, this angle is, this much part is 30 degree. So we can also say angle BTX is also 30 degree. Angles in the alternate segment. See, theorem says that angle formed by a chord and a tangent. So this angle will be equal to the angle formed by the same chord in the alternate segment. So by same logic, if this is 30, so this angle BTX will also be 30 degree. Okay. Now we can get one more thing from here. See, this whole angle is 90. So 70 minus, sorry, 90 minus 70, this will be 20 degree. And if this angle is, that is ABT is 20, so ACT is also 20 angles in the same segment. So we can get this angle to be 20 degree. Okay. Now we can find this angle BTP. BTP. This is 30. So this angle will be 150, 180 minus 30. And hence we can find this value. So let's write down. See, we can write angle BAT is equal to angle BTX, and this will be equal to 30 degree. Here you can write angles in the alternate segment and again you can write angle ABT, angle ABT is equal to 90 minus 70, that is 20 degree. With this information, we will find angle BTP. BTP, that is equal to 180 minus BTX. So you get 180 minus 30, that is 150 degree. See, now in triangle BPT, using angle sum property, we can find the value of the angle, third angle. So let's write in triangle BPT, using angle sum property, we can write 150, that is angle, in terms of angle, first we'll write angle ABT plus angle BTP plus angle APT is equal to 180 degree. Now we know this ABT is 20, this is 150, plus angle APT is equal to 180. So angle APT is equal to 180 minus 170, that is 10 degree. This is your answer. Let's see this question. In the given figure, O is the center of the circumcircle ABC. Tangent at A and C intersect at point P. Given angle AOB is 140 and angle APC, that is this angle, is 80. Find the angle BAC. So let's begin first by joining OC. See, if we join this O to C, so we get a quadrilateral AOCP or APCO. So now we can begin solving the question. Join OC. So we get a quadrilateral. In quadrilateral, APCO, you get angle APC plus angle AOC is equal to 180 degree. Opposite angles are supplementary. Reason being, radius and tangent, they form 90 degree. So this angle is 90, this angle is 90, that is 180. So the remaining angles will be supplementary, that is 180. So here, from here we'll find angle AOC. This is 80 degree given angle A. So we get angle AOC is equal to 100 degree. See, this much is 100, this is 140. So we can easily find angle BOC. So angle about a point is 360. So using this fundamental, we can write angle AOC plus angle AOB plus angle BOC. This is equal to 360 degree. Reason, angle, the word around. See, angle AOC is 100. Angle AOB is already given. Angle BOC you have to find. So angle BOC will be 360 minus 240. So you get 120 degree. So angle BOC is 120. Now we have a relationship between the angle formed at the center of a circle and angle formed at the remaining part of the circumference of a circle. So using that relationship, we can further write angle BOC is equal to twice angle BAC. BAC. So here you can write angle formed by the RBC at the angle formed by the arc BC at the center of the circle is twice the angle formed at the remaining part of the circumference. At the remaining part of the circumference. So angle BOC is 120. Divide this value by 2, you get angle BAC, that is 60 degree. So angle BAC is 60 degree. Let's see this question. See, it is given that PQL and PRM are the tangents to the circle with center O at points Q and R respectively. S is a point on the circle such that SQL is 50 and SRM is 60 degree. So we have to find QSR, that is we have to find this angle. So it is very easy. See, OQ and OR and OS, all the three are the radii of the circle. So this is equal to this is equal to this. And we also know that radius is perpendicular to the tangent. Hence, L, Q, O and MRO will be 90 degree. So we can write here angle OQL and angle ORM. Both are equal to 90 degrees. You can give the reason, that is radius is perpendicular to the tangent. Okay, if this whole angle is 90 degree, we can easily find OQS, that will be 50 degree. Similarly, ORS will be 40 degree, 30 degree, 90 minus 60. So we'll find these two angles. So angle OQS will be equal to 90 minus 50, you get 40 degree. Similarly, angle ORS will be 90 minus 60, that is 30 degrees. Now we'll use the property of isosceles triangle. Now we see OSQ is an isosceles triangle and we know that base angles are equal. So using that logic, we can say this angle is equal to this angle. That is OQS is equal to OSQ. So we begin by writing in triangle, in isosceles triangle, OQS angle OQL is equal to angle OSQ, and both these angles are equal to 40 degree. Reason is base angles are equal. Base angles are equal. Similarly, in triangle, in isosceles triangle, OSR, we know angle ORS will be equal to OSR, angle OSR, and this will be equal to 30 degree. Again, same base angles are equal. Same reason you can write. Okay, we have to find angle QSR. So, angle QSR is nothing but sum of the angle OSQ plus angle OSR. And both the angles we know, OSQ is 40 degree and OSR is 30 degree. So the sum is 70 degree. So here it is asked QSR is equal to 40 degree. So this statement is false. So your answer will be, the statement is false. Since angle QSR is equal to 70 degrees. Question. See, it is given that in the figure, if PQR is a tangent to the circle at Q, whose center is O, and AB is got parallel to PR. So AB is parallel to PR. Okay. And angle BQR is 70 degree, then AQB is equal to, that is we have to find this angle AQB. Okay, so if AB is parallel to PR, then we can say this angle 70 degree is equal to this angle, because these are alternate interior angles. So we can write here angle BQR is equal to angle ABQ. ABQ is equal to 70 degree. Reason? AB is parallel to PR. It is given in the question. Hence, alternate interior angles are equal. So using the properties of parallel lines, we can say both these angles are equal. Now what we'll do, let this point be D, or let this point be C. See the line, this TQ line is passing through the center. That means OC is the OC will is perpendicular bisector of the chord AB. That is line drawn from the center of the circle to the chord bisects the chord. So we can say AC is equal to BC. We have to prove these two triangles congruent. See, triangle ACQ and BCQ. If we can prove them congruent, then we can say angle A is equal to angle B by CPCT. So angle B is already known. Then This will be also 70, and then by using angle sum property we can find angle Q. So let's write in triangle QAC and triangle QBC, AC is equal to BC. So AC is equal to BC. Reason? Line drawn from the center of the circle bisects the chord. So this is the reason, and we know OC is obviously perpendicular to AB. A perpendicular drawn from the center of the circle to the chord will bisect the chord. Okay. Now we can write angle ACQ. Angle ACQ is equal to angle BCQ. Both are equal to 90 degrees since OC is perpendicular to AB. And CQ is equal to QC, common side. Okay. Then by SAS criteria, side angle side. So triangle QAC will be congruent to triangle QBC by SAS criterion. Hence, we can say angle A is equal to angle B. So we can say angle QAB is equal to QBC, angle QBC, which is equal to 70 degree. This we have proved it here. So from 1 and also by CPCT. So both the angles are equal by CPCT and the value is equal to 70 degree from equation 1. Now using angle sum property, we can find the angle Q. So angle QAB plus angle QBC plus angle AQB will be equal to 180 degree. Using angle sum property. Okay. These two angles are already known. 70 plus 70 plus angle AQB is equal to 180. So you get angle AQB is equal to 180 minus 140. That is 40 degree. So option B is correct. In this figure, it is that AT is the tangent to the circle with center O such that OT is 4 centimeters. Angle OTA is 30 degree, and we have to find AT, this length. We have to find this length AT. Okay, what we'll do? Join O to A. See, we draw a perpendicular from O to point of contact, and this will be 90 degree. Radius is perpendicular to tangent. So we get a right angle triangle, and then using trigonometry we can find AT. So we can write in right angle triangle OAT in right angled triangle OAT. Cos 30 will be equal to, see, base upon hypotenuse. So base is 80 upon OT. We know cos 30 is root 3 by 2. So you can write cos 30 multiplied by OT will give you 80. So cos 30 is root 3 by 2 multiplied by OT, that is 4. So you get the answer root 3 cancel out. So you get 2 root 3. This is your answer. See, in the given figure, angle AOB is 125 and we have to find angle COD. That is, we have to find this angle. So, using the information that opposite sides of a quadrilateral circumscribing a circle will subtend supplementary angles at the center. So, I'll write down the statement in simple word. It means angle AOB plus angle COD will be equal to 180 degree. So we already know AOB is 125 plus angle COD 180. So angle COD is 180 minus 125, that is 55 degrees. So this is the correct answer. So here we are using the information that a quadrilateral, opposite sides of quadrilateral, see, opposite sides of the quadrilateral circumscribing a circle circumscribing a circle subtends supplementary angles at the center of the circle. This question, in the given figure, O is the center of the circle. Tangents at A and B meet at C. If angle ACO is 30 degree, then we have to find angle BCO, that is this angle. Then angle AOB, that is at the center, and angle APB, angle formed on the circumference. So let's see. See, to find angle BCO, what we can do, we can prove these two triangles, triangle OAC and OBC, congruent. See, it is easy to prove since OA and OB are the radii of the circle, both will be equal. AC and BC are tangents from the external point. So, tangents from the external point are equal in length and OC is common. So, by triple S criterion, we can say both the triangles are congruent. Hence, this angle, that is ACO, is equal to BCO by CPCT. So, let's write down the solution. See, we'll first solve this part to find angle BCO. So, let's prove the triangles congruent. In triangle OAC and triangle OBC, see, OC is equal to CO, common side, then AC is equal to BC. These are the tangents from the external point. Tangents from external point to the circle are equal. Next, OA is equal to OB. Radii of the circle. So, we can say triangle OAC is congruent to triangle OBC by triple S criterion. Therefore, angle ACO is equal to angle BCO by CPCT. Thus, angle BCO is equal to 30 degree. So, the first part is done. Let's come to the second part. We have to find angle AOB. Now here you can see AOBC is a quadrilateral, and we know that radius is perpendicular to the tangent. So here this angle becomes 90 degree and this angle becomes 90, OBC. So sum of all the angles of quadrilateral is 360 degree. You already have angle A and angle B 90, so 180. So remaining angle, the sum of remaining angles will be 180. So we can say in quadrilateral AOBC, angle AOB plus angle ACB is equal to 180 degree. AOB we have to find, and angle ACB is 30 plus 30, that is 60 degree. 180. So what we get, angle AOB is equal to 120 degree. So second part is also done. Now let's come to the third part. See. Here we see angle APB and AOB. There is a relation between these two angles, that is this angle and this angle. See, angle AOB is the angle formed by the arc AB at the center of the circle, and the same arc AB is forming this angle P in the remaining part of the circle. So we know this, if this angle is x, so this will be twice x. That is, angle formed at the center will be twice the angle formed at the remaining part of the circle. So using this information, we can write angle AOB is twice angle APB. So you can write the reason, that arc AB subtends angle AOB at the center and angle APB in the remaining part of the circle. Of the So we already know angle AOB is 120 divided by 2, you get angle APB, that is, it is 60 degree. So this is PB. Understood the solutions well? Please like, share and subscribe. Keep practicing and best of luck for your board exams. Thank you so much.